Okay, this is a video on density. Density, by definition, okay, the amount of mass per given volume of a substance. So you've always heard, how dense something is, or how dense someone is, but it's mainly referring to how many grams, okay, usually in grams, could be milligrams, could be kilograms, whatever, just a mass unit per a volume unit. And in many cases, it's going to be milliliter or liter or even cubic centimeter. So, how we would write this, the term per is actually referring to division. So this, say for example, like miles per hour, you would write that like this, miles per hour. Well, in density, it's grams per milliliter or grams per cubic centimeter. And remember that these two things right here, okay, are actually equal to each other. Those are the two equal volumes. They just have to be two different units, but they're the equal amount of volume. All right? So we'll go ahead and now they know the definition, and we know that that's a mathematical relationship between mass and volume, mainly grams over milliliters or grams over liters, or pretty much mass over volume. Then we can solve some problems with that. Now, the formula for density looks like this: mass over volume. And like I said, that mass unit could be grams, it could be kilograms, milligrams, centigrams, volume, milliliters, centiliters, cubic centimeters, any of those volume units. Okay? So now, obviously, what we have right here is we have three variables. Now, what you should be able to do by the time you're done with this video is, if I give you any two of these variables in a problem, you should be able to solve for the third. Okay, so if I give you density and mass, you should be able to solve for volume. If I give you mass and volume, solving for density. And if I give you volume and density, you should be able to solve for the mass. Now, there's a nice way to kind of shortcut or remember this formula. Okay, and I'm sure many of you might have seen this before. Okay, I'm going to go and give it a circle. All right, I'm going to put density here. I'm going to put volume here. I'm going to put mass here. All right, so how this is going to work is, it's going to be hard to see because in the video, because you guys can't see my hands, but what I'll do is I will cover up whichever variable I want to solve for. So for example, if I wanted to solve for density, I'll cover up density, and I'm left with mass. Okay? So I got mass right here over volume, and here's my over line right there. So I have mass over volume. Okay? Trying that again. I went ahead and just rewrote it with just one letter, but that's how I would solve for density. If I wanted mass, then I would cover up the mass, and I'm left with density and volume next to each other, which would be multiplication. So if I want to solve for mass, I'm going to go volume times density. And then lastly, if I wanted to solve for volume, I would take the volume out, and then it would be mass divided by density would give me volume. Okay, just a little shortcut. I will have this up in the corner of our problems as we do them, so you guys know what direction we should go. All right. Okay, so suppose we have 23.50 milliliters of a liquid, and it masses at 35.062 grams. Okay, calculate the density. So first thing I'm going to do, I'm going to draw my little circle: density, volume, mass. Okay, and in this case, I'm solving for density, so I would cancel that out, and I end up with mass over volume. So when I rewrite this, I need to write out, it's simply going to be one division problem. So I'm going to put the mass, which is 35.062 grams. Notice I kept my unit in there. You need to always have your unit. And then volume is 23.50 milliliters. Now, I didn't cancel any of my units out, nothing like that, which means my answer should have this unit. Okay? So, you go ahead and do the division real quick on your calculator. And what you should get is 1.492 grams per milliliter. Now, don't forget, because we are dealing with now two different measurements. Okay, that's a measurement and this is a measurement. It's no conversion going on, which means now we have to go back to our sig fig rules of multiplication and division. We'd have 1, 2, 3, 4 sig figs here, 1, 2, 3, 4, 5 sig figs there, which means 4 is going to be the number of sig figs in our answer. Well, as it so happens, it turns out to be exactly 4 sig figs, so we wouldn't have to round or cut any numbers off or anything like that. So 1.492 grams per milliliter. All right, let's go ahead and take a look at another one. All right, the density of a metal object is 8.7 grams per cubic centimeter, and the dimensions are 3 centimeters by 1.2 centimeters by 3.61 centimeters. Okay, what I'm trying to find here is going to be the volume. So I'm going to make my little circle. I know it's density, mass over volume. I want to find the, well, in this case, actually, I want to find the mass, because I actually can use this right here to find the volume. So I'm looking for mass, which means I need to get volume times density. Okay, so first thing I'm going to have is 8.7, okay, grams per centimeter cubed. Now, there's another way to write this, okay? If I can also write this like this, 8.7 grams over cubic centimeter, okay? Because, I mean, that's pretty much what it means, the same thing. It's this many grams per cubic centimeter. So, we have that right there. We'll hold on to this. That's the mass. And then we'll quickly do the volume. The volume is going to be, because it's the length by width by height, sometimes you're going to have the measurements. You have to calculate the volume. Now remember to maintain your sig figs when you're doing your calculation. So the answer being 12.996 cubic centimeters, but we have two sig figs as our lowest. We have our sig figs here, 1, 2, 1, 2, 1, 2, 3. So 2 number of sig figs is what we're going to have. So 13 centimeters cubed. Now, what do I need to do? I need to multiply, just like that. So I will go 8.7 grams per cubic centimeter times, what, 13 cubic centimeters over 1. Well, take a look. Cubic centimeters are going to cancel out. I'm left with grams. So my final answer will be in grams, since I'm trying to find the mass. Final answer being equals 113.1 grams, but because of my sig figs, I need 2. So in this case, 1, 1, that 3 is not larger than 4. Okay, it's not 5 or greater, so I would leave it alone. And there's my 2 sig figs. And there's my final answer. Okay? Okay, this is our last problem. An object has a density of 3.012 grams per milliliter. Okay, so, one more time. Density, mass, volume. I don't need, let's see, I'm trying to find volume, so scribble that out. I'm left with mass over density. So, take my mass value, which is 1.02 grams, okay, and I divide it by 3.012 grams per milliliter. Okay? Now, because we have grams on opposite sides, okay, one's on top, one's on bottom, right? My grams are going to cancel out. And, oops, I should have milliliters. I'll have my milliliters as my answer. So, do the math. And I get 0.33865, blah, 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 blah. But we should know based on sig figs, 1, 2, 3, we're only going to have 3 sig figs in our answer. So 0.33, I need to look at my third sig fig, okay, or actually my fourth sig fig over here, this guy right here, to see if I would round that up to a 9. Since 6 is greater than 5, yes, I would, so that'd be 0.339 milliliters. All right, if you guys have questions, make sure you ask in class or write a comment below.